All right, and let's see if you really know what you're doing. 130. Pretend.
I don't even know what was
What's that? Who's mumbling over here? You know what's going on, right?
No.
Oh, and then the truth comes out. The truth comes out.
She was already. I didn't come back to my spirit, so yeah. Yeah.
Yeah.
21. They wanted to 21.
Yeah, you gotta get the one eventually. You gotta see that sequence. Yeah, a good quiz question, I think.
No, thank you.
Oh, it's really not hard once you figure it out.
Okay.
No, I'm being serious. I'm not being facetious. That's the right word. 130, what is it? A sub, is it n? Equals a sub n minus 1 over 2, or 3 times a sub n minus 1 plus 1, right? First one is if it's even. This just tells you what you're plugging it into. And I think the subscripts can tend to throw people off. It just is telling you what term you're dealing with. So if you're looking for the third term, you plug in the second term. If you're looking for the 10th term, you plug in the 9th term. If you're looking for the second term, you plug in the first term. Well, the first term is what, 21? That's an odd number. That means you got to plug it in down here. So it's just 3 times whatever that number is plus 1. Well, what's 3 times that number? 3 times 21 is 63 plus 1 is 64. Now that's an even number, so you got to plug it into this top one. Well, all you do is you take whatever the number is and divide it by 2. What's 64 divided by 2? 32. And now it's still an even number, so plug it in, divide it by 2. 16. Even, divided by 2. 8. Even, divided by 2. 4. Divided by 2. 1. So that was not the best one. But that would be the case. So you plug it in, go from there. What about here, just to make sure you really know what you're doing, 30. We'll see what happens there. Maybe it'll be a little more interesting. Plug in 30. Good. All right. Ooh, where are we at now? Oh, it's all over the place. Oh, yeah. All right, this is a good one. It's a better one. 35. Plus 1. Did it work? Yeah. Woo. Yeah, it's thinking Ulam was wrong. Oh my goodness. All right. We got a good one then. So 30, that you're gonna have to help me out if I make a mistake here. So we cut that in half. I at least wanted to cut it in half and get an odd number. So 15. 3 times 15 is 45 plus 1. 46. Cut that in half. 23. 70, right? 35. Cut it in half. Oh, another odd number. 105, 106, cut it in half, 53. Holy cow. 106, 159, 160. Cut it in half, 80. Oh, now we make some progress. 80, 40, 20, 10, 5, 16, 8, 4, 2, 1. Woo. That was right?
Yeah.
Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Yeah, I wonder which one takes the longest to get there. Like between 1 and 100. What number would take the longest? So, all right, just curious. All right, last section. Geometric sequences. Talk about common ratio. We're going to find the sum of an infinite geometric sequence and just regular geometric sequences. Instead of adding, we multiply. So if I told you this was going to be a geometric sequence and the first two terms were 8, what would the next term have to be? It would have to be 16, because I said you have to multiply. The only way to, what do you multiply it by 4 to get 8? 2. And then 32. And then 64. And then 128. Okay. So it's got to be a multiplication. That common, the value we multiply by is called R, or the common ratio. This keeps getting messed up for some reason. I think down there where it says we have, that would be, this is what goes there. This is how we find our R value. You just take any term and you divide it by the previous term. And they all have to be the same. So 128 divided by 64 is 2. 64 divided by 32 is 2. 32 divided by 16, 2. 16 divided by 8 is 2, and 8 divided by 4 is 2. So it has to be the same for all of them. Yeah, some of them are obviously really easy. Some of them are not so easy. You got to look at it a little bit harder. We can define a sequence recursively. Recursive, and we talked about that yesterday, means the next term is determined from the previous term. You always got to substitute in the previous term to get the next. So this one can be defined more than one way. Here's your recursive formula. The next term is, we get it from multiplying the previous term by R. And that's all you're doing here, multiplying each one by 2. That's not that difficult to see. First term is a sub 1. Again, your common ratio is R. Okay. Now we want to do the a sub n, like the general form, like we did for arithmetic. For arithmetic, a sub n was a sub 1 plus n minus 1 times d. That was for arithmetic. For geometric, the nth term, a sub n, is determined by this formula. A sub n equals a sub 1 times r to the n minus 1. If you look at it, I think it's not that hard to see here because, all right, this is just 4. This is 4 times 2. This is 8 times 2, which is the same as 4 times 2 squared. Okay, this is the 16 times another 2. So all we have to do is tack another 2 onto here, which makes it 2 cubed. This makes it 4 times 2 to the 4th. And this is 4 times 2 to the 5th. Well, this is your first term, second, third, fourth, fifth, and sixth. So it's easy to see here that the power is 1 less than the term. okay? So that's 2 cubed. The cubed is 1 less than the fourth term. Fifth term is 2 to the fourth. So this is your general form for geometric. That's your general form for geometric, okay? All right, for the geometric sequence, find each of the following. All right, now this one is, I just throwing it at you just to make sure you understand what it's asking. The first two are obviously really easy. The third one is just making sure you put it in the right form. A1, the first term is just 3. A sub 1. R is whatever you're multiplying by. This one you can just look at it. We're multiplying by 2. A sub n is just we're putting it into this form. This is what it's all it's asking for. So A sub n is the first term times r to the n minus 1. So it's going to be 3 times 2 to the n minus 1. So we're not actually solving for a value. That's all we're doing is just write down the general expression for that one. Because I think a couple of your homework problems ask for A sub n, and there's a tendency to want to do too much. This is all you got to do. Just done. Now, there are times we want to find a specific term. All right, I want you to go ahead. I want you to list the first 4 terms. Do that first before you go to solve it. So on that, what would be the first 4 terms of that sequence? I want to make sure you understand how to go about that. First 4. Carter, what do you think?
10, 12, 14.4, and 17.28.
Okay, good. I just want to make sure we were good on that. You start with the number 10 and you just multiply it by 1.2. You take that answer, multiply it by 1.2. Take that answer, multiply it by 1.2. That's all you got to do. All right, to find the 23rd term, we want to use that A sub n equals A sub 1 times r to the n minus 1. N is 23. My first term is 10. R is the 1.2. 23 minus 21, or excuse me, 23 minus 1 is 22. All right, what do we end up with? Zachary, let me know. Get round it to 3 decimal places because it's pretty lengthy. When you get it, Zachary.
552.061.
All right, I agree. 552.061. So if you want, no matter what term you want, you can just plug it into the formula. That doesn't work with every sequence. It does work for arithmetic and geometric. Okay. We want to add these together now. So let's take, the first 10 terms and add them together, or the first 20 terms and add them together. The sum can be represented by, this is the actual formula. This is just another way to represent the geometric sequence. So that is the sum symbol. Now this is not the first letter A there, first number. So don't write that one down. Just copy down the formula. That's the word, formula. All right, I just want to demonstrate how it works here. And you've already done these, so we know how to plug in 1, 2, 3, and 4. If it's in this format, it's going to end up being geometric. All right, what do I get? Just kind of do it mentally. What do you get when I plug in 1? What do I get when I plug in 2? What do I get when I plug in 3? What do I get when I plug in 4? All right, Sydney, help me out there. What do I get when I plug in 1? 3. How about when I plug in 2? 6. Plug in 3. 12. Plug in 4. 24. All right, take a look. 3, 6, 12, 24. It's geometric. We're multiplying by 2, which is that number right there. That's our R value. The first term's a 3. So if it looks like this, it's automatically geometric. Well, I can add those up. 3 and 6 is 9, plus 12 is 21, plus 24 is 45. Okay, since I know it's geometric, that means that this formula will also work. Since that's only 4 terms, it's not that difficult to write it out. But I just want to make sure you understand that this works as well. First term is 3. 1 minus 2 to the 4th power, because that's my n, over 1 minus 2. What's 1 minus 2 to the 4th power? Negative 15 over negative 1. Negative 45 over negative 1 is 45. So using that formula will arrive at that same value as writing everything out. Okay. So what you have to do first is you have to look at a sequence and you got to say, is it geometric? If it's geometric, we use this formula. If it's arithmetic, we use the other formula. All right, I do not want any decimals. Okay, so this one gets a little bit ugly, I guess, in terms of the values you get. So don't just type it in and get decimals. We want to work with the fractions, keep it in fraction form. First of all, what is the R value? What am I multiplying by to get each term? If it's not obvious, going to the right, left to right, then you work backwards and you divide. What's 6 divided by 2? 6 divided by 2 is 3. What's 2 divided by 2/3? It's only going to be geometric if they're all the same. It's going to be 3. And then 2/3 divided by 2/9 is also going to be 3. So that means my R value is 3. So I'm going to use, in my first term is 2/9. So I'm going to use that sum formula that says a sub 1 times 1 minus r to the n over 1 minus r. All right, so let's use that. Plug in everything where it goes. First term is 2/9. 1 minus 3 to the 12th power, because n is 12, over 1 minus 3. Figure out, use your calculator, it's fine. What is 1 minus 3 to the 12th? Yeah, obviously it's going to be a larger value, or it should be. Negative 531,440, right? All right, now I want to simplify this whole mess into basically a reduced fraction. I don't want you to just type it in and give me a decimal. What I would tell you to do is, all right, let's work outside here. What is 2/9 divided by negative 2? You can use your calculator for the bits and pieces to get there. Go.
Negative 1/9.
It's negative 1/9. Well, negative 1/9, that just means I'm going to have a 9 in the denominator, negative 1 at the top, negative 531,440 over 9. Will that reduce any more? Will anything go into both the numerator and denominator? Well, there's only 2 choices. It's only a 3 or a 9. Will a 3 or a 9 go in the numerator? Test it on your calculator if you're not sure. And I got a negative times a negative, so in the end it's going to be positive. And it doesn't reduce. Okay, it's just going to be that. So I want that to be the answer. I think they typically give this in the back. So like that's how the format they're looking for is they want it in fraction form, reduced fraction. Okay, you know this is geometric after testing it. You got to test it. I figured out, all right, R is 3, first term is 2/9. Not every sequence is guaranteed to be geometric. Whoops, hold on. The second one here. All right, if you're giving it to you in that format, go ahead and write that down. Okay, if it's in this format, and it has to be specifically this format, you got a constant in front, a value to I minus 1, and it goes from 1 to a number. It is guaranteed to be geometric. Okay, this is where was it? No, I don't think it was there. Right, this is in this format right here. Okay, and this is why we did this. We wrote it out, we showed you it was geometric. If you got a constant to a value to the I minus 1, it is guaranteed to be geometric, okay? And so I can use that formula. So the sum is going to be 1 minus, or a sub 1 times 1 minus r to the n power over 1 minus r. Yes, you could list them all out and add them up. You could do that if you wanted to. We're going to use the formula for practice. The first term, a sub 1, is 4. The r is the 1/2. So that is 4 times 1 minus a half to the what power? 8 over 1 minus a half. Okay, what is 1 minus a half to the 8th power going to look like? Or what is 1/2 to the 8th power as a fraction? What is 1/2 to the 8th power? As a fraction. Well, think about it. That is just 1 over 2. Whoops. Both of those are to the 8th power. You just need to know what 2 to the 8th power is and put it over 1. All right, so it's going to be 1 minus 1 over 256. That's what that's going to be. All right, now I'm hoping that most of you can just look at, don't touch your calculators. What is 1 minus 1 over 256 without touching a button? You should be able to look at that. This is kind of like a lost skill for that one. Cole?
255 over 256.
Got to be 255 over 256. What you do is you make that the 256 over 256 minus 1 over 256. So now this becomes 4 times 255 over 256 divided by a half. Now there's different ways you can go about finishing this, but I think I would do it this way. What's 4 divided by a half? It's not 2. 8. So that becomes an 8 times 255 over 256. You can multiply 8 by 255, but it would be easier to see, will it simplify any? Will 8 go into 256? And it will. How many times? 32. So that cancels. That becomes a 1, that becomes a 32, and in the end, I got 255 over 32. And just double check and see whether that'll simplify more. Will anything go into both of those? Really, 5 goes into the numerator, but 5 doesn't go into 32. And so really, there's not a whole lot to check because of the n numbers there. So that's your answer, 255 over 32. For that. So these can get a little bit nasty in terms of just the numbers. All right, flip it over. This isn't on your guided notes. Just pay attention to this slide. All right, this is what we call an infinite series. It doesn't end. Obviously, it has a pattern. What would be the next number? 1 over what? 32, then 1 over 64. What would happen if we added those all together? Okay, typically you're saying if I'm adding an infinite number of things together, it has to keep getting bigger and bigger and bigger. That doesn't have to be the case. This actually adds up to 4. This will add up to 4. Okay, so if you take this 2 plus 1 plus a half plus a quarter plus, I'm going to go to fraction here, an 8 plus, what's next, 16 plus a 32nd. Okay, it's going to keep getting closer and closer. If we do this infinitely, it's actually going to equal 4. Okay, it's never going to get bigger than 4. Plus a 64th. Here's why it'll never get bigger than 4. Let's see if I can explain this. All right, if you got a 2 by 2 square, what's this area? 4. We know that, right? It's not rocket science. All right, think about our series that we had, our sequence. We had 2, we had 1, we had a half, we had a quarter. So here's what I want to do. How do I represent 2 of the 4? I cut it in half. If I cut it in half, that's going to be how much here? 1. If I cut this in half, how much is this piece? A half. If I cut this in half, a quarter. If I cut this in half, an eighth, a 16th, a 32nd. That'll be a 64th, 128, 256. Okay, so we keep going all the way down, right? We're never going to fill that. We're never going to get bigger than 4. You keep adding that little piece, you're actually going to end up just filling it in at the end. It's just going to keep kind of cascading all the way down. But 2 plus 1 plus a half plus a fourth plus an eighth plus a 16th plus a 32nd plus a 64th is going to have equal 4. Okay? And so this is now on your guided notes. If we do have an infinite geometric sequence, the R value has to be less than 1, though. Okay? It cannot be bigger than 1. Because like something like this right here, obviously, if we keep adding these up, they are going to go to infinity. But if we got a geometric sequence that is decreasing, which means you multiply it by something less than 1, it will have a finite sum. So if we have an infinite geometric sequence, 1 to infinity, this is the formula. Whoops. Okay, that's the formula. You take the first term divided by 1 minus R. Now let me just flip backwards for 1 second. What was my first term here? My first term was 2. My R was a half. 2 divided by a half is 4. Okay, so then you don't have to add everything up. All right, take a look at this one. See what you come up with. Think about it. Okay, the first thing you need to do is figure out whether it's geometric. And this one's not as easy to see. You can't just say, oh yeah, I'm multiplying by 2. No. So when you can't tell, what do you have to do? How do you test it? Okay, Zachary, can you explain it? All right. When you're trying to do this, and it's not obvious, this is when you divide terms. So you would just say, all right, I would take 27 over 32 divided by 9/8. Well, yeah, that doesn't look great, but you got to do it. 27 over 32 times 8/9. Your calculator will give you 0.75. It's 3/4. Same thing. Okay. Then you take 9/8 divided by what? 9/8 divided by 3/2, which is 9/8 times 2/3. So this is a lost art, canceling. 3 goes into 9 3 times, 2 goes into 8 4 times. What's it equal? 3/4. And so we think it's going to be 3/4, but we're still going to check 3/2 divided by 2, which is 3/2 times a half, which is 3/4. So now I know for sure that that's my R value. So R is 3/4. The first term we obviously know is 2. The sum is the first term over 1 minus R. So it's 2 divided by 1 minus 3/4. 2 over 1/4. All going to add up to 8. All right, so that's how you go about that. But you got to identify and make sure it's geometric. You got to identify and make sure R is less than 1. R is less than 1 will make this decrease. It'll make it get smaller. So 2 to 3/2 to 9/8. That's getting smaller. If it's getting bigger, there is no sum. Only if it's getting smaller. All right, this is like the last, like I said, the last section of chapter 11. We'll review a little bit tomorrow, quiz on Monday. On going away part.